So the next aspect under atomic structure now is what? Let us look at what we call what? Isotope, isobar, and isotone. Let us take it one after the what? Other. We have isotope. See, look at the isotope. Is a phenomenon that exists between two or more atoms of the same element having the same atomic number but different mass number. Isotope exists between what? Two or more what? Atom of the same element. Atom of the same element with the same atomic number but different what? Mass number. That is what we call what? Isotope. These are the example of elements that is undergo what? Isotope. We have hydrogen 1, hydrogen 1, 2, and hydrogen what? 1, 3. Look at these three hydrogen. I said the three of them have the same atomic number 1, 1, 1, but their mass number are what? Are different. So the isotone is what? Isotope. The phenomena that occur between two or more atoms of the same element have the same atomic number but different what? Mass number. This one is called protium, deuterium, and what? And tritium. This tritium is a radioactive part of what? Of isotope, hydrogen isotope. So, and another example of isotopic element we have also have what we call what? Oxygen 816. We have oxygen 817, and we have oxygen 818. So the three oxygen have what? The same atomic number, but different what? Mass what? Mass number. And we can also have it in what? In carbon. Carbon 6, 12, carbon 6, 13, and carbon 6 for what? 14. So this carbon 614, we can also call it what? Carbon dating. It's a radioactive what? Element. This one can also call it what? Ozone. It's also a what? Radioactive what? Element. And we can also have it in what? In nitrogen. Yes, we have it in nitrogen, nitrogen 714, and nitrogen 7 what? 15. And we can also have it in what? In chlorine. You know, we have chlorine 1735 and chlorine 1737. So there are more than what? More than this. So you can observe that what? All these elements, they are atoms of the same element, but they have the same atomic number, but different what? Mass number and neutron what? Neutron number. That is what? Isotope. And what are the uses of isotope? We can use isotope. Where can we use it? So the isotope, the uses of what? Of isotope. Uses. The uses of what? Of isotope. Number one, we can use isotope to determine the age of specimen. To determine the what? Age. To what? Determine age of what? Specimen. So we can use what? Isotope to determine what the age of specimen, like rock, e.g. yes, rock or bone. So if you see bone on the field now, you can take the bone to the what? To the lab and get what? Carbon dating. Get what? This carbon what? Carbon dating as one of isotope of what? Of carbon, of a carbon. So we can use what? To determine the age of what? Of rock. The amount, the age of what? Of rock, or the age of what? Of bone, of dead what? The bone of dead woman or animal. You can use what? This carbon dating to what? To determine the what? The age of it. You can also use what? The isotope as a tracer. As a what? Tracer. What is tracer? Tracer is the one of the application of what? Of radioactive what? Of the isotopic element. We can use the word to determine the biological reaction or biological pathway. So the metabolic pathway, what? Meta what? Bolic what? Pathway in living organism. So we can use what? The isotopic element as a what? As a tracer to determine the what? The metabolic what? Pathway or the biological reaction of the what? Of a living organism. The next one is what? We can also use what? Isotope to determine or for treatment in medical. Treatment of what? Of cancer. We can use isotope to what? For treatment of what? Of cancer. We can also use for nuclear weapon or nuclear what? Nuclear power what? Generation. We can use isotope to what? In nuclear power generation or for nuclear what? Where what? Weapon. True. In farming. First what? Control in what? In farming. That's all about what? Isotope. Phenomenon that exist between two or more atoms of the same element, but different. They are of the same element that have the same atomic number, but different mass number and number of neutrons. So the next one that we need to check now is what? Let us look at what? Isobar. What is isobar? If you look at this thing, the three of them, we have abi. See, in Greek, whenever you see the word iso, simply means what? Constant. Or what? The same. But if you have the word what? Topes, we call it what? Atomic what? Atomic number. If you have the word what? Bar. Bar here, we call it what? Mass number. If you have the word what? Tone. Tone means what? Neutron what? Neutron number. So if you now combine it together, is what? So isotope means what? The same atomic number. Isobar means what? The same mass number. The same mass number. Isotone means what? The same number of what? Of neutron. Or if you could still remember under thermodynamic process, if you have what? Isobaric. Baric here means what? Prayer. So if you have what? Isocoric. Coric here means what? Volume. So this means what? A reaction that is occur at constant pressure, occur at constant what? Volume. We also have isotonic. The word tonic means what? Solution. Tonic from what? Tonic means what? Solution. Iso means the same. A solution that have equal or a constant solution. Under osmosis, where we have hypertonic and hypotonic solution, we have isotonic what? Solution. So yeah, what is isobar now? So you know that what bar here means what? Mass number, abi. So isobar is a phenomenon that is occur between two or more atoms of different elements. Code it. Two or more atoms of different elements. Isotope, two or more atoms of the same element. So this isobar occur in what? Two atoms of different species. But isotope occur in what? In two atoms of the same species. But in isotope, they have different mass number and a neutron number, but atomic number are the same. But in isobar, it's a phenomenon that is occur between two or more atoms of different elements, but they have the same what? Mass number, different atomic what? Number. Isobar, two or more atoms of different elements having the same mass number but different atomic what? Number. Example of what? Of isobaric. Example of isobaric, we have what? Let me use nitrogen 7 and nitrogen 7 14. Atomic number is 7, mass number is 14. And look at carbon 6 and what? 14. See now, the phenomenon that occur between nitrogen and carbon is what is called isobar. The atomic number here is 6, here is 7. Mass number are what? Are the same. The atom of different elements, different atomic number, but the mass number they have in common is what? Is isobar. If they may give you any element, what you need here is what? Just try to know that what? If they have the same mass number, the common mass number is their what? Their isobaric element. Their isobar. So the next one is what? What we call iso what? Isotone. What is isotone? Yeah. The isotone, I said tone there means what? Neutron. So the isotone is a phenomenon that occurs between two or more atoms of different species or two or more atoms of different elements that is have the same number of neutrons but different atomic number and what? And mass number. Isotone, the phenomenon that is occur between two or more atoms of different elements having the same number of neutrons but different mass number and atomic number. See, this is the example of what? Of isotone. If you have isotone, let me use helium. Its atomic number what? 2, mass number 4. And we have hydrogen, tritium, 1 and what? And 3. Look at this. This is helium and hydrogen. Two atoms of different species, different elements. Atomic number difference, mass number difference. But if you want to note the what? The neutron number, what we do? Neutron number here is what? 4 minus 2. It will give us what? 2. Out of this place, neutron number will be what? Neutron will be 3 minus 1. It will give us what? 2. So they have the what? Then what? Neutron number, but their mass number and atomic number what are different. That is isotone. We can also have isotone in this element too. Yes, in nitrogen 7, 14 and carbon 6, 13. Look at this. What is the phenomenon between the two elements? Is this isotope or isobar or isotone? Their mass number are different, atomic number are different, but any atom of different element, what do we call it now? So you find the what? The neutron number, subtract it. Neutron is what? We have 14 minus 7 to give us what? 7. Here we have what? Neutron number should be what? 13 minus 6 to give us what? 7. That is all about isotope, isotone, and isobar.